So in fifth module, we're going to learn just two programs. One is the blinking LED light, which has been asked in previous year question papers. So what are the components required here? Are Raspberry Pi is required, SD card, monitor, HDMI cable, keyboard, mouse, and power supply, which are common. And then you have one LED, red LED, one red LED, one blue LED, and two 1 kilo ohm resistors. Okay, so the description is you're trying to control the state of LED by changing it from on and off, and then what you're doing is you need to give the pins, that is your general pin input output pins, as 17 and 27 respectively. That is your description. Okay, uh, and then the state of LED should be toggled while having to code, and you're doing this by coding and giving and the desired output should be observed. So circuit diagram, you have a Raspberry Pi, you have these input output general input output pins, right? So from there you connect it to two LED bulbs. That is, one is blue one, the other one is red. So you have two 1 kilo ohm resistors, that is resistor 1, resistor 2. Now what you're doing is you have to, your key points is you're creating a blink.py, blinkever.py, and then these two should be done in sudo python, and then you have blink py. Okay, so you're doing this to watch the LED blink 2 times. That is, you have two different LEDs, so it'll blink 2 times, and then you are using sudo python. This is the execution code, sudo python, and then blink, this is your file name. You're doing this to watch the LEDs blink forever. There are only 4-5 lines which have to be written over here primarily. First, you are inputting Raspberry Pi dot GPIO. Okay, so you're inputting it as GPIO. So you're so that you can, this is a shortcut term which is going to be used in the program throughout. So GPIO. So this is your first statement. Second statement is you have this board, right? That is BCM 2835. So what you're doing is GPIO dot set mode. So you're setting the mode so that it can use it to the GPIO uses BCM processor. Okay, so these two are your different steps. Other than this, you have, as it is mentioned, so your GPIO dot setup, you're setting up the set mode, not setup, set mode. No, it is setup. Set mode is only for setting the processor. This is set up. Okay, what happens is GPIO setup GPIO setup of GP7. You need to put 17 pin, right? 17th and 27th pin. So 17 comma GPIO dot output. Your the value you're going to use the output function, right? So you're using output. Same thing, GPIO dot setup 27 comma GPIO out. Okay, so you've set it. Then what you're doing is you need to wait for a minute. So after setting it up, what you're doing is you're giving the output. Okay, so you're turning it on. So you're making the same thing, GPIO dot output. You want the output of 17 to be GPIO dot high. That is, you're turning it on. Then you have output of 27. Same thing for 27. Instead of 17, write 27 and then write high. Then you wait for a second before it stops blinking. So you wait for 1 second, time dot sleep of 1. And then GPIO output 17 comma GPIO low. That is, you're turning it off. Same thing, you're turning it off, and then you're ending it by putting it to sleep. So that is timer dot. Then you're solving it for blink forever. Okay, so what you're doing is the same thing. You're inputting GPIO, same thing. Whatever you did till now, it is the same. But what you're doing here is the only difference. After you're setting it to output pin, then you make it as while 1. Then you write the same thing. If GPIO output of 17 and then GPIO, you're turning it on, you make it sleep for a minute, and then you turn it to low. So you it's like while the condition is true. So when you're doing all this, and then you're making sure that it runs infinitely. So that is why you keep doing this. So all these will get repeated on loop. So what you're doing here is you're using a temperature sensor. You're trying to detect the temperature and record it. So same thing, Raspberry Pi, SD card, monitor, HDMI cable, keyboard, mouse, power supply, one red LED, one blue LED, two 1 ohm resistor, push button, and then jumper wires, breadboard, then one buzzer, and then temperature sensor. So what you're doing here is this is your connection now. So you have a DS18 18B22. You have the temperature sensor Raspberry Pi, right? Using which rings a buzzer whenever the temperature crosses either high or low. So that is done using Arduino board. This is for Raspberry Pi. What you do is you're connecting input outputs over here, and then one more you're giving it to a LED bulb, and then here you have a resistor. So you go to the code part of it. In the code, you're inputting OS. You're inputting the operating system. You're inputting glob and time. So what you're doing is os.system. You're making the module to probe W1 GPIO. So your W1 GPIO and then W1 therm. So whatever this W1 is, it's your value, okay, before you go to devices. Then you have three things. First you have base, then device file and device folder. By base directory, you're setting it to devices. System, bus, W1, devices, okay. This is what happens. And then for device folder, what happens is globe.globe base directory plus 28 star of 0. Then you have device file, that is device folder plus W1 of slave. Then you define you read the temperature, the raw temperature, that is your normal temperature. F is equal to open device file comma R, and then lines you're reading to is equal to F dot read lines of, and then F dot close. So now you have to return lines. So you have return lines. Then you have definition read temp. So what you're doing here is lines is equal to read temp of raw. So you're getting the raw data. Then while line of 0 dot strip of -3 is not equal to yes. So when it is not equal to yes, what you're doing is you're putting it to sleep. When it is not a minimum temperature or something, you're putting it to sleep. And then what you're doing here is you're using lines is equal to read temperature raw. You're getting the raw temperature value. Then equal position. You're checking if it is equal to the minimum position and maximum position. So what you're doing here is line of 1 is equal to find T is equal to. Okay, so you're checking if it is equal to this temperature. If it is not equal to -1, that is if it is an existing temperature, then you put temperature string of line 1, the first line, equals to position plus 2. So you're getting the string value. So you're using float temperature string divided by 1000 to get the Celsius value. Here for Fahrenheit value, you're multiplying it by 9.0 divided by 5.0 plus 32.0 because you're using float values. Then you return temperature C comma temperature F. So while true, print read temp off and sleep 1. So the current room temperature is recorded.